Hi guys, Teacher J here. For this video, you're going to learn how to solve limiting reactant problems in stoichiometry. Hi guys, so you are here in Ask Teacher J channel, and for today's video, I am going to teach you how to solve a limiting reactant problem. So we have here a problem wherein 2 grams of zinc metal strip is placed in an aqueous solution containing 2.50 grams of silver nitrate. The reaction is Zn plus 2 moles of silver nitrate to form silver solid plus zinc nitrate. Okay, so we have here 4 questions. The first one is we want to know which is the limiting reactant. We also need to find out how many grams of zinc form, as well as the amount of zinc nitrate formed in grams, as well as the excess reactant left at the end of the reaction. Okay, so I will teach you according to how I teach this step by step. So the first thing that I usually do when I solve stoichiometry problems involving limiting reactant problems is for me to solve for the molar masses of all the reactants and all the products in the chemical reaction. So step 1, okay, is for me to determine the molar masses. Determine the molar masses. Okay, so at this point, you can pause the video and solve for yourself the molar masses of zinc, silver nitrate, silver and zinc nitrate by yourself. To also practice and to also check if you are good enough and fast enough in terms of your clerical skills in reading the periodic tables and also properly adding the appropriate number of atoms in the compound. Okay, so I'm going to write everything and organize everything for you first. Okay, so this is what I usually do. I write everything in advance, especially the molar masses, because during our problem solving process later, we are going to deal with a lot of molar masses. So it would be wise for us to prepare everything in advance. The molar mass of zinc is 65.38 grams per mole. Okay. The molar mass of silver nitrate is 169.87 grams per mole. Okay. And the next one is the molar mass of silver is 107.87 grams per mole. Okay. And last but not the least, the molar mass of zinc nitrate is 189.36 grams per mole. Okay. So that's the first part. Okay, determination of the molar masses. Next is what I'm going to do is I will be converting the reactants, okay, namely the 2 grams of zinc and the 2.5 grams of silver nitrate into moles. But of course, I will be using the molar masses. Okay, so let's go to step number 2. Okay, convert grams of reactants to moles. Okay, so I will be converting the grams of zinc into moles of zinc. So the moles of zinc is equal to 2.00 grams of zinc to form moles of zinc. Okay, so this one, by applying dimensional analysis, we want to get rid of the grams of zinc. So we want to place here G zinc because we want to cancel it out, and we have to place the mole of zinc here at the top. Okay, so grams, mole over grams. Okay, so that would mean that we need to use the molar mass here as our value. But the value of our molar mass is in grams per mole. So we need to do the reciprocal or divide 2 grams by 65.38. So if you are going to write this one, you have to make sure that you write the 1 mole of zinc. Okay, basically that is 65.38 over 1. So that's 1 over here at the top and 65.38 grams here at the bottom. Okay, so you can pause this video so that you can solve this item on your own. And let's see if we have the same answers. Okay, my answer for this one is 0.0306 moles of zinc. Okay, take note that we have 3 significant figures here, 2, 0, and 0. So you would or you should report also your answer in terms of 3 significant figures. So the significant figures here are 3, 0, and 6. Okay, so that's the significant figures. So if you wonder why I did not count the number 0 here, then that is not significant. Okay, so you need to review your significant figure rules so that you will be guided as to how to properly report your answers. Okay, let's now go to the moles of silver nitrate, moles of AgNO3. For the moles of AgNO3, you have 2.50 grams of AgNO3, and we still do the same thing. Divide 2.50 grams by the molar mass. Okay, apologies for the... Okay. So grams AgNO3. And then we have here moles of AgNO3. So I prefer to really place the complete solution so that the viewers of this video who are really new to stoichiometry will be guided as to the correct units during the solving of stoichiometry problems. For this one, we have 1 mole of AgNO3 and 169.87 grams of AgNO3. Okay, so pause this video and answer this part for yourself. Okay, by yourself. Okay. So my answer for this one is 0.0147 moles of AgNO3. Okay. So that's it. We are done already getting the moles of zinc and moles of AgNO3. The next step will be to determine the limiting reactant. Okay, number 3. Determine the limiting reactant. So for the limiting reactant, we have actually many approaches that we can do to solve this. But I usually teach my students what I call the product method, because this is somehow easier and it still gives the best results to the students. I mean, not the best, but it gives us the correct result to the students at a shorter period of time, because the method of getting the answer is not so complicated. Okay, so what do you do when you perform product method to determine the limiting reactant? The first thing that you have to do is, number 1, you have to choose any product as your basis. Any product as your basis. As your basis. Okay. So we have here 2 products. Okay, let's go back to the equation. We have here Ag and we have here zinc nitrate. So usually I choose the compound or the element which is the simpler one, because I don't want to have a difficulty in the conversion of molar masses and other stuff. So I just use Ag. Okay, so the silver. But either way, if you choose silver or you choose zinc nitrate, you will still get the same answer. So I still choose AG for this one. You can choose zinc nitrate if you want to explore another route, okay, or another way. Next is to solve for the moles of Ag. But this time, you're going to solve the moles of Ag in terms of, or with respect to, the amounts of your zinc and the amounts of your silver nitrate. So as to how to do this, okay, let's start first by getting the moles of Ag based on the amount of zinc or the moles of zinc that we have. Remember that the calculated moles of zinc that we have is 0.0306 moles of zinc. So that will be our starting point. Okay, moles of zinc. Okay, after that, we are going to convert this moles of zinc to moles of Ag because that is our goal. Okay, as to the numbers or the values that we're going to place here in the numerator and the denominator, remember that we're going to use the stoichiometric ratios. Okay, and we can find that in the chemical equations. Okay, so we can look for that here. So this is relationship between Ag and zinc. Okay, so you have to look that one here. Okay, in the coefficients. So it says here that for every 1 mole of zinc, you have 2 moles of Ag. So that's the relationship that we're going to use. 1 zinc, 2 Ag. So we're going to write 2 Ag and 1 zinc. So in that way, we can solve for the moles of Ag based on zinc. Okay, you can pause the video to solve for your own. Okay. So the answer for this one is 0.0612 moles of Ag. Okay, let's solve again for the moles of Ag, but this time we are going to base it on the amount of AgNO3 that is present, or the amount of silver nitrate. Okay, remember that we have solved for the moles of AgNO3 already. We have 0.0147 moles of Ag, 0.0147 moles of Ag, and then we're going to convert the moles of Ag into, I have a mistake. Okay, apologies. This will be moles of AgNO3. Convert the moles of AgNO3 to moles of Ag. And we can do this by again going back to the chemical equation and look for the stoichiometric coefficients. So with respect to Ag and AgNO3, as you can see here, for every 2 moles of AgNO3, you have 2 moles of Ag. So the ratio between them is 2:2. 2/2. Cancel units. Since 2/2 is just equal to 1, then we can immediately write 0.0147 moles of Ag. Okay, we're now done calculating the moles of Ag based on the 2 reactants. But how are we going to assess, or how are we going to determine which of the 2 reactants, zinc and AgNO3, is the limiting reactant? So the process here is just simple. Between the 2 values here, 0.062 and 0.0147, you just need to choose which is the larger value, and you just need to choose which is the smaller value. Of course, between the two, this one is smaller. Okay. And the other one is the larger value. Okay. With this, the smaller value of the moles of Ag actually corresponds to the limiting reactant. So in this case, the limiting reactant is your AgNO3 because that reactant yielded or gave us a value of moles of Ag that is smaller. Okay, so the smaller value of the chosen product will give us the signal that, the reactant used to get this value is the limiting reactant. On the other hand, the larger value will give us the idea that the amount of reactant used to get this value over here is the excess reactant. Okay, so that is zinc. Okay, so yeah, so we now know that our limiting reactant is AgNO3 and our excess reactant is zinc. We have to take note that when we know already the limiting reactant, our basis of calculations for the succeeding steps will be based already on the limiting reactant. Okay? Limiting reactant. So, I would recommend that when you start calculating with respect to the limiting reactant, just immediately use the value of the limiting reactant in moles to make your life more convenient. Do not start anymore with the grams, with the 2.50 grams of AgNO3 because you will then go back to the process of converting it to moles, which will be useless because you already have the value of moles over here. The next step is to, according to the problem, determine the amount of Ag and ZnNO3 that is formed. Okay, of course, for the amount of Ag, okay, what's the next number? Number 4. Okay, for the moles of Ag, okay, I think we are looking for the grams of Ag, not moles. Grams of Ag. Okay, the good thing here is that we already knew that if we base our calculations on 0.0147 moles of AgNO3, we are going to get this value of moles of Ag. So we just base everything on the limiting reactant, right? So I can just immediately write it here, the 0.0147. But I really want to follow the process of calculating so that you will not get lost. So for the purposes of formality, we have to start first with the value of your limiting reactant because that will be our basis of calculation. Okay, the next thing that we're going to do is to convert the moles of AgNO3 to moles of Ag. Okay, just like what we did here. I actually am just copying what I saw here at the top because the gist is just the same. We just need to convert AgNO3 to Ag. 2/2. Okay, cancel. And then the next thing that we're going to do is to convert the moles of Ag into grams of Ag because that's what we're looking for. Okay, to determine the grams over mole, we have already calculated the molar mass earlier, which is great. Okay, since we don't need to calculate it again. The molar mass of Ag is 107.87. Okay, 107.87 grams per 1 mole. Okay. Okay. Pause the video if you want. Okay, so that you can solve it by yourself. Okay. My answer for this one is 1.59 grams of Ag. Okay. So I will box this red because this is a very important answer. Okay. Yeah, I might also box this one because this is the first question, the first question's answer. The next number that we're going to solve, or the next item that we're going to solve, is the grams of zinc nitrate that is formed. Okay, grams of zinc nitrate. Oops. Again, we have to start with the value of your limiting reactant, AgNO3, and then we need to convert the moles of AgNO3, okay, to moles of zinc nitrate. Okay, I usually write the units first because this gives a clear idea that, or this gives me a proper direction as to what transformation of values I am expecting and what values inside the parentheses should I put. Okay, for this one, since this is mole to mole conversion, we need to use the stoichiometric ratios that we can find in the chemical equation. So between AgNO3 and ZnNO3, okay, so the ratio is for every 2 AgNO3, there is only 1 ZnNO3. Okay, so the ratio is 2 AgNO3, and then, oops, there is only, okay, apologies, okay, 1 zinc nitrate. And last but not the least, we need to convert the moles of zinc nitrate. Okay, we need to convert the moles of zinc nitrate to grams of zinc nitrate. So good thing we have calculated the molar masses already, so it will not be a hassle for us anymore. Okay, so let's go back. The value of zinc nitrate is 189.36. 189.36, and then 1 mole. Okay. Kindly pause the video so that you can solve by yourself. Okay, my answer for this one will be 1.39. I still use 3 significant figures. Okay, so remember that one. I won't anymore highlight the 3 significant figures, okay, as often as possible because I might forget. Okay, but it's a given. Okay, if you have 3 significant figures as your initial values, your answer should be also reported in 3 significant figures. Okay, so we're done with the amounts of Ag and the amounts of zinc nitrate in grams. Last but not the least, we are required to determine the grams of excess reactant that is left at the end of the reaction. To do this, okay, our excess reactant is zinc. Okay, oops. Remember that our excess reactant is zinc. So let's write excess reactant. Okay, just for us to really remember that fact, we have here zinc. So to solve for the excess reactant, I mean the amount of zinc that is in excess, grams of zinc in excess. Oops. Okay, apologies. Grams of zinc in excess. So we are going to use this equation. Grams of zinc initial minus the grams of zinc that is consumed. Of course, the initial part is easy because we already know that it's 2 grams of zinc initially. But as for the grams of zinc consumed, we still need to do stoichiometry for this one. To solve this part, again, you need to start with the amount of limiting reactant, as it will be our basis of calculation. Okay, so you have moles of AgNO3. The moles of AgNO3 should be converted to moles of zinc, because that's what we want to happen. We want to convert the corresponding we want to convert the AgNO3 to the corresponding zinc, okay, that it requires for the reaction. Last but not the least, we are going to convert the moles of zinc to grams of zinc by using the molar mass. For this one, we're going to use the coefficients. Okay, so we need to go back to the chemical equation between zinc and AgNO3. Okay. So for between zinc and AgNO3, okay, here, for every 1 mole of zinc, there is 2 moles of AgNO3. So let's write that here. 1 mole of zinc, 2 moles of AgNO3. And then we're going to write here 1 mole of zinc. The molar mass of zinc is, I think, 65. Am I correct? Yeah, 65.38. Oops. 65.38 grams per mole. So we're going to write that here. Okay, don't forget to cancel your units. Okay. Kindly solve this one first. This portion over here. 0.0147 times 1/2 times 65.38. You can pause the video, okay, so that you can solve by yourself. Okay, this one is the molar mass. Molar mass. Okay. Okay. Okay, so what we're going to do is to equate it again, rewrite the 2 grams, and write our answer here. So my answer after the calculation is 0.481. So we can now do the subtraction and determine the grams of zinc in excess. My answer is 1.52 grams of zinc in excess. All right. So we are now done with our video, or with our problem, I mean. However, I need to add something just for me to show the conservation of mass in this stoichiometry problem. So remember that our chemical reaction is, okay, zinc plus 2Ag to form, sorry, I have a mistake. Okay, 2AgNO3 to form 2Ag and zinc nitrate. Okay, so what I'm going to do here is I will be enumerating all the values that we have calculated and that were given so far. In the problem, we have 2.00 grams of zinc. We have 2.50 grams of AgNO3. Okay, just to show the conservation of mass. Of course, even though not all reactants are fully reacted, conservation of mass still holds true. We're going to add the 2 values to give us 4.50 grams. So this means we have a total of 4.50 grams that were loaded. Okay, that was loaded in the chemical reaction. Okay, so now for the values of our Ag and our zinc nitrate, let us recall the values. The value that we got for the mass is 1.59 grams of Ag, and for the zinc nitrate is 1.39 grams. Okay. Please take note that aside from the two reactants, we have an excess of zinc that we can retrieve at the end of the reaction. Okay, assuming that you have the possible means to retrieve this zinc substance here that is in excess. Okay, the amount of the excess zinc is 1.52. Okay, you need to sum it all up, and by virtue of the conservation of mass, okay, please, okay, add all the three values just to make sure, and then you will get the value of 4.50 grams, indicating that the amount of, or the mass of the reactants should be equal to the overall mass of the products plus the excess reactant found at the end of the reaction. So that's it for my limiting reactant problem. I hope you learned something from this video, and I hope to see you soon in my other videos related to general chemistry and stoichiometry. Okay, thank you so much, and see you next time. Bye!